Greetings, everybody. My name is Charles Falstrom, and I'm going to be walking you through my Module 4 application where I created this presentation that talks about the 5 E's instructional model. So let's get started. The learning objective. So the whole purpose of this presentation, I'm going to be showing you about the 5 E's instructional model. I'm going to talk a little bit about how it's compatible with the Universal Design for Learning principles, and I'm going to show you an example math unit on volume that incorporates the 5 E's instructional model. So the 5 E's, it consists of 5 distinct instructional phases. They are in order. You begin with engagement, then exploration, explanation, elaboration, and finally evaluation. As this graphic shows, all of these 5 phases are interconnected and they build off of one another. So phase 1 is engagement, and that's really about trying to activate students' prior knowledge, getting them interested into the unit or topic of study, and you're trying to make connections and kind of bridge the new material that you're going to be covering with their past experiences and trying to get them motivated with learning. Phase 2 is exploration, and so during this part, the students are trying to do some things on their own. You're not guiding them necessarily, but they're trying to figure some things out independently. So they're going to be confused. They might have conflicting ideas, unanswered questions. This is an important phase because it allows teachers to see what students know and don't know and what the gaps in understanding are, which is really important for the next phase, the explanation. And so during explanation, this is pretty much direct instruction. So now that you've already got an idea of what students know and don't know, and you kind of have a better feel for that, now you can begin filling in those gaps of what they don't know. You can correct misconceptions, and you're really starting to solidify knowledge for the students. You're trying to be clear in your instruction and really make sure that students are putting things together and making connections. After explanation is elaboration. Once students have received instruction, it's really critical that they get other experiences that are going to help them deepen their understanding and construct additional understanding. So this is giving them different types of activities, collaborative opportunities where they can apply what they've been learning. And then the final phase is evaluation. And this is where teachers assess what students have learned, what they know, what they don't know. And of course, assessment should always be an ongoing process. You're going to be formatively assessing students, but in this phase, this is more like when a summative assessment would take place. Universal Design for Learning principles, they are sort of a guideline for how teachers look at their classroom environment and curriculum, and the whole point of it is that you're trying to eliminate any barriers for learning for students. You want to make everything as accessible and equitable as possible. So one way you do that is you look at the 3 different brain networks: the recognition network, the strategic network, and the affective network, and you target each of those networks and try and find ways to make sure that students can actually access the material and learn. Are the Universal Design for Learning principles compatible with the 5 E's? Yes. Each of the different phases fall into a different network. So the engage and explore phases both fall into the recognition network. The explain and elaboration phases fall into the strategic network. And then all 3 phases fall into the affective network. So if you do choose to teach using the 5 E's model, you can also address the needs of all learners using the Universal Design for Learning principles. They align perfectly, and again, if you do choose to use this instructional model, you should be able to meet the needs of all learners because you will be able to target each brain network and eliminate barriers for learning. So a sample instructional unit, I'm a 5th grade teacher, so this is a unit that I teach every year, the concept of volume. And these are just sort of the basic standards that students need to understand. They need to recognize volume as an attribute of solid figures. They need to understand the concepts of volume measurement. They have to calculate volume by counting or using unit cubes. And then they also have to apply their understanding of addition and multiplication and move beyond using unit cubes to apply those formulas for adding and multiplying and use that to solve real mathematical problems that involve volume. So beginning with the Engagement phase, you have to activate students' prior knowledge. So they're going to need to have an existing knowledge of addition and multiplication. They're going to need to have a conceptual understanding of area, which is for two-dimensional. Volume takes it to the third dimension. So students know to multiply how to get the area of basic shapes. Volume is just adding another layer to that understanding. So some guiding questions that we can ask students is, what types of patterns do they see? How many layers are there? How is calculating volume similar to calculating area? And what type of equation or expression matches your array? So for engagement, what I would do is I would begin by showing students some unit cubes in a cardboard box and ask them if they can think of a way to find out exactly how many cubes fit inside the box. So sort of posing a real world problem that's going to pick their curiosity and get them to maybe, honestly, I know I'm using a box, but try to get them to think a little bit outside the box, without just having them open a math book and just give them what a formula for volume is. Like, let them try and think about it themselves. And this kind of goes right into exploration, giving them some unit cubes, allowing them to construct their own rectangular prisms with exactly 10 unit cubes. We can point out that there's different combinations. There's different ways to construct. You could do 2 layers of 5. You could do 5 layers of 2. You could do 1 stack of 10. So there's different combinations. So getting them to see that, getting to see that there's different floors to the building with the layers that they're building, because volume is really about seeing how many different, that's that third dimension, right? You have the width and the length, but now we're adding the height. So getting students to start to construct their own models, play around with that would help me see if they can figure out what volume is on their own and what they understand and don't understand in terms of making an array or how many layers there are, stuff like that. Explanation, that would be me finally giving them direct instruction on, hey, this is what volume means. It's how much space does a solid 3-dimensional figure occupy? How much space is inside of this shape? And then showing students strategies to calculate it, giving them opportunities to practice independently and collaboratively. And then for elaboration, I would get a bunch of different size cardboard boxes and have them try to calculate the volumes of those. They could measure them with rulers or measuring tapes. I could give them a limited amount of unit cubes where they could be able to use the cubes to figure out how many cubes long, how many cubes wide, how many cubes tall, and then use their understanding of what volume means to calculate the volume without actually having to fill the box up with a bunch of cubes. Asking students if they can think of a different combination of length, width, and height that would result in the same volume. And then maybe even taking it to something more fun, seeing if they could figure out the volume of my classroom. Evaluation, so some types of formative assessments that I could do during this. Obviously, anecdotal observations on my part, exit tickets, their homework, independent practice. I could use quizzes or Kahoot to assess them. And then a summative assessment, I would try and construct something where they have to show a rectangular prism with different dimensions. They should be able to tell me which number is the length, which number is the width, which number is the height. I would have them calculate volume using both addition and multiplication strategies. I would ask them questions on what is the volume of 1 layer, of 2 layers, etc. And then I would have them actually construct their own prism out of unit cubes and have them tell me what the volume is and label the dimensions. So in conclusion, I believe that the 5E's instructional model is a helpful tool for teachers to reflect on your instructional practice and lesson planning, because you're breaking up your unit of study into 5 different phases. You have to really make sure you're carefully addressing each phase, and those give good opportunities for you to reflect on your practice. And you're also making sure that you're targeting the needs of students. Not only are you making sure that you're going to be engaging them, you're going to give them chances to explore and collaborate. You're also going to try to extend their learning, and you're also making sure that you have solid assessments built along the way. So when all of those things happen together, your teaching can be very, very effective. Too often as teachers, sometimes we focus more on the explanation part and the direct instruction, and we don't give as much time as maybe we should to some of those other areas. So if this is followed faithfully, it can be very powerful. And these are my references. So thank you for watching.